Okay. So just a little bit about the exam to kind of start out with. So I have multiple sections on different days. So this may not make a lot of sense necessarily for you guys. But the exam will be made available Thursday late afternoon. Now, we're still going to meet and do more review on Friday. So my suggestion would be I would wait and take it until after that. But really, once it's open, you can take it any point kind of Thursday evening, Friday during the day, and then I'll leave it open. I try to think about what I did in college, and I know that Friday nights and Saturday nights probably you're not going to want to take exams then. But I'll kind of leave it open all the way throughout to the end of the day Sunday. So Sunday was always the day when I caught up on everything or was doing studying for an exam on Monday or something like that. But you'll basically, whatever kind of fit, meets your schedule in the way that you like to kind of study and take exams, you could take it any point Thursday evening, Friday, Saturday, or Sunday, okay? Once you log on and start, you'll have, and I'm still finalizing it, so I'll give you more exact time limits kind of later this week, but an hour to 15 or about an hour and 30 minutes. I'm not exactly sure where I'll set it, kind of depending on the final makeup of the exam. But it'll be about 15 to 20 multiple choice questions and then about 2 short answer, right? So those short answer, you could just see 1, you could see 2, and they'll kind of have multiple parts. I might end up kind of making them all kind of, just one short answer, but it might have A, B, C, and D, right? So I would say if I had to kind of give the breakdown, it's about 75% multiple choice and about 25% short answer. Now, the short answer I give so that I can grade for a little bit of partial credit. So I want you to show as much of your work as possible for that. Right? Multiple choice is just graded whether or not you get it correct. So you don't have to show anywhere for that. But for the short answer, I want you to upload kind of your answers and show all of your work. So this could be with pictures. A lot of people will just honestly take pictures from their phone and upload them. You can write your work down and kind of scan it and upload that. You can do it in Word or Excel and upload those documents. Or however you're doing your work, and getting your answer, I want you to upload it in that format. Okay. So yeah, so if you're doing it by hand, feel free to take pictures and kind of upload just pictures of your work. Let me think. So I won't be using like a lockdown browser. So if you want to use Excel, all right, you want to use your notes or you'll have all the resources available to you. So as we're working through these practice exams, the exam will look similar to those, but it might be like just a little bit harder, right? Because I'm going to expect that you have kind of more resources available to you than if you were kind of here in person taking it, right? Any questions kind of about the exam that I haven't mentioned? Yeah. So if you look at the practice exam, this kind of gives you a good idea of what the exams will look like. And I'm not going to ask you for like individual Excel formulas or anything like that. It's really nothing related to Excel. Now, you could use Excel as like a calculator if you wanted to or something like that, but it won't be any kind of Excel work, no. Any other questions kind of related to that exam? And one resource I'll mention here once we get going, I have that formula sheet up on Canvas. That would be a good thing to kind of have and use. And I'll kind of walk through how you can make it even more useful as we kind of start doing some review today. Okay. Any other questions on that?
Yeah, if we are using Excel as the calculator, would you want us to upload that as a form of work as well?
So if you're using it for the short answer portions, then yes. Then as part of kind of your upload, you should be uploading those your Excel where you did the work. Does that make sense?
Yes, thank you.
Okay. The other thing, just kind of housekeeping, I want to get out of the way. I will be recording. So Wednesday is supposed to be a study day. I mean, it is a study day. But I will be here at 12 recording, just like me working through more problems. So I just have giving you more resources. If you want to show up at 12 and in this classroom on Wednesday, there should be more than enough room. If you want to log on, I'll have a Zoom link. I'll kind of get that up on Canvas. If you want to log on and watch it live, you can do that. I have no expectations of you doing that Wednesday, right? If to study, you can take it completely off. If you want to, I'll post the recorded video. So if you want to watch it Thursday or Friday or whenever before you take the exam, by all means, please do that. I do not expect you to show up Wednesday. I'm just using Wednesday to record that additional video, okay? So I just want to get out as many resources, you seeing me work through as many problems as possible. So as you're working through the practice exams or looking at them, you can kind of, if I'm stuck on this one, you'll then have a video where you can go and see how I worked through it. So basically by the time that the exam is posted, Thursday, I'll have worked through every single problem from practice exam A and B. So we'll work through practice exam A today, and then that video I record Wednesday will be like the rest of practice exam A problems. In my other section I have on Tuesday, Thursdays, I'll be going through practice exam B with them. So as I'm going through with them, I'll post those videos to our class section's YouTube page as well, so that by the time my Thursday class is over, which I think is 1:45, every single problem on those practice exams, you can find a video where I've worked through it. And they'll be in like smaller section, like smaller groupings of numbers. So it'll be a little bit easier to find. Well, I'm stuck on practice exam B problem 12. It'll be very easy to identify on YouTube what video that's in. You can kind of see me work through it. Does that make sense? So I kind of mentioned, but basically it's going to be open and it's going to be on Canvas from late afternoon Thursday. I don't know exactly what time yet, probably around 4 or so. And it'll be open all the way through the end of the day Sunday. So you can log on and take it at whatever time. Now, once you start, you're only going to have a certain amount of time, somewhere between an hour and 15, hour, 30 minutes to complete it. But whatever fits best into your schedule. Any other questions? Okay.
For the practice exam, is there going to be practice short answer questions?
So I don't have any up there. I would think about really any multiple choice question that's on those practice exams. I could basically just convert it into it. When I say short answer, it's any question you could see on the practice exam, just like without the 4 possible answers, right? I could ask you for a mean, but I just don't give you 4 possible answers. Does that make sense? Yeah.
Yeah. Thank you.
Yeah, you don't have to be like drawing any graph. There's no graphs or anything you have to draw. It's literally just a multiple choice question without giving you the 4 possible answers. So it'll be like 15 to 20 multiple choice, and then 1 or 2 short answers with kind of multiple parts. I haven't finalized it yet. When I record the video Wednesday, I'll give exact numbers and an exact time, but I'm still kind of playing around with to make sure that the difficulty of the exam is exactly where I want it. All right, so as we work through things today, we have this formula. So this is any formula you could ever need that we've talked about. Now, some of them, like the mean, I don't know, do you really need that? Right? We're adding the numbers up and dividing by the number of numbers we have, right? So there's a lot of stuff in here. Here I'm just telling you that the standard deviation is the square root of the variance. So there might be a lot of additional stuff on here that you may not even use on the exam, but this is any equation that we've ever looked at, okay? Now, as we work through these problems, what I would suggest doing is maybe print this out, right? Or download it and save it and insert text boxes or type next to these formulas, or if you print it out right next to them, write out what these equations means. As I work through all these problems, as we work through them together, I'll mention, like, if we have to use this later today, I'll say, this is how you find the mean for a discrete random variable. Well, if it was me, I would write next to that mean of discrete random variable. And then you can have this resource when you take the exam, right? So make it a lot easier for you to identify what formulas go with what types of problems, okay? Yep, so that was the next thing I was gonna mention is it's already up there on Canvas. If you go to files under the practice materials, right? So it's been there for a hot second. Now, one thing I'll mention, if you click on this, it's a mess if you view it in the web browser. I don't know why that is, some type of compatibility issues, so you'll have to download it. I think if you look at the PDF, maybe it looks okay in the web browser. We'll find out here in a second. But kind of downloading that to kind of make sure that's probably the fail-safe. I don't know why this is not showing up in the web browser, but it's the same thing just in the PDF format. There we go. Yeah, so the PDF looks okay if you view it on the web browser.
Yeah. You said like write down next to it. Are you going to be going through a lot of those equations on Wednesday?
I won't go through like the formulas exactly. As we work through the problems, I'll mention what formula you would need to use, and so then like you'll know. Yeah, I'll say, hey, we're doing this problem. This is the formula we use, and so as you're kind of working along with me, you can kind of identify what those are. Yep. One final thing, and this will be like in the title. I'm going to kind of jump into the problems here today, but. Or in the description, not the title of the exam. When we get to the exam, I don't know why, but Canvas doesn't work well with Safari. So I will put up a reminder multiple times, but try to take it in Google Chrome, Firefox, or Internet Explorer. I don't know why, but Safari, viewing some of the symbols and the equations, they just show up blank. So I always say I write them right on Canvas, or I'm uploading them on Canvas in Google Chrome. So I know that if I can see it, you can for sure see it in Google Chrome. So if you have that available to you, I would use that. And then kind of the next order, if I'm going in order, Google Chrome, Firefox, Internet Explorer, avoid Safari, okay? All right, oh, and I had all these, let me see. Practice exam A is what we'll start working through today, okay? So I'm gonna skip the first few, they're a little bit easier. I do wanna do some review, but I wanna focus on ones that we might kind of have a little more difficulty with. Like I said, I'll eventually work through those, but for today, I wanna start out kind of reviewing these contingency tables, okay? So here I've got these two events, which are whether or not someone's older than 55, I'm calling that event O, and then, not older than 55 or O complement. Whether or not they want marijuana legalized, we'll call that LM. And then whether or not, if they don't want it legalized, we call that LM complement. So the way that we said we read these tables is the totals tell us the probabilities of the events in the row or the column. So the probability someone's older than 55 is 0.25. The top four left cells all represent intersections, right? So the probability that someone's older than 55 and doesn't want marijuana legalized would be 0.11. Just kind of a quick review of those contingency tables. So if I asked you to find the missing value of X here, what's one way we could do this? So remember, how did we say we find these total probabilities? Like if I left these off here, how could you actually determine what those totals are? Yeah, add across the rows and down the columns to get those totals. So 0.14 plus 0.11 is 0.25. And here I won't switch to the kind of writing yet because it takes a little bit of time and it's easy enough to do. 0.52 plus X should give us 0.75, right? So 0.52 plus X should be equal to 0.75. If I rearrange that, X would be equal to 0.75 minus 0.52, or that 0.23, okay? So that's easy enough, remembering that we can reproduce the totals adding across the rows or down the columns. Now, what I could have also done, an example that you could see, I've written the exam, so I'm telling you this reason. Maybe I leave this out. How could I find Z here with 0.14 plus 0.52, which would give me that 0.66, okay? So that one should be, I think, fairly easy points in this exam. 6, if we have paid attention at all to when I've talked about these contingency tables, hopefully should be really, really easy points. If I want the probability that someone is older than 55 and they do not favor the legalization of marijuana, what am I looking for here? I'm looking for the probability of an intersection, right? This and this. I said these top four cells represent intersections. So the probability someone is older than 55 and does not favor marijuana legalization is 0.11. It's as simple as that, right? So I can almost guarantee you'll see a question where I'm just asking you to identify the intersection of two events using a contingency table, okay? Any questions on either of those before we keep moving?
When you see that keyword, and is that the only one?
Yep, so this is just kind of a reminder. Let me switch over my video here, and because for most of the rest of the class we'll use this anyways. So anytime we're thinking about the word and, we're thinking about an intersection. I'm gonna have to switch this here in a second. Let me see. All right, there we go. It should pop up here in class in just 1 second. All right, so anytime I see and, I'm thinking about the intersection of two events. Right, this was kind of the and. Anytime I'm thinking about or, I'm thinking about the union of the two events. Okay. So the intersections I can get directly from that cell. Okay. Yep.
What's the difference from that and like we would have to take one of the four top ones and like divide it by that 2%?
You're jumping the gun, but we'll get there. Yep. Okay. So we got those two out of the way, right? So the next one is going to be given that a person believes in the legalization of marijuana. Now what's the probability they're older than 55? So anytime we see this word given, now what we're thinking about is given some event, which now our given here was what? That they want marijuana legalized, right? Given that, what's the probability that they're older than 55, which we were calling this kind of O and LM. That's the way it was instructed to us, right? But I'm writing out a little bit more so it's a little clearer. Well, anytime we want the conditional probability, if we go to our formula sheet, right, I go up here, I have the general form of the equation, right? So a conditional probability is the intersection of those two events divided by the probability of what I'm conditioning on. So let's just write this out in the context of my example, because I essentially have my A and my B here, right? So if I want the conditional probability, this is going to be equal to the intersection of these two, so being older than 55 and wanting marijuana legalized. And I could write LM is equal to yes and write out the older than 55 here if I wanted. And I'm going to divide that by the probability of what I'm conditioning on, which is what's on the right-hand side of that given line, or that conditional line. So here, right, I now want the probability of an intersection and just the probability of an event itself, right? And I could have written this kind of in here too, just to be a little bit clear. So now when I go, so this is how I find my conditional probability. I go back to my contingency table. What's the probability someone's older than 55 and wants marijuana legalized? Well, that's just 0.14, right? What's the probability that someone wants marijuana legalized? Well, that is where I would go down to the total column. So what I'm really saying is here, of the people who want marijuana nationally legalized, what proportion of them are also older than 55? So that ends up being what, 0.14 over 0.66. I think it's something like 0.21212 or something. If we round that to the second decimal, that would give us that 0.21. Now, anytime that you have something that's, like I said, this ends up being something like this. Anytime you have something that, is goes out 4 or 5 decimal points, round it to whatever the answers are displayed as, right? Here I've got them all to the second decimal. So take this answer, round it to the second decimal, it would be 0.21. I'm never going to give you options like 0.21 and 0.22 on the same one, so that if you make a rounding error or something that you would get the answer wrong, okay? But they will have to be displayed to some decimal, right? I can't just have this going out for forever, okay? Does that get your question that you were, Yeah, so that's where we're looking for a conditional probability. Okay. Any questions on that one for a?
So if the question was like switched, it was like given that a person's 55,
Mm-hmm.
and then you
So-
do the other way around.
Yep, so if it was given that someone is 55 or older, basically these would flip-flop. Now, we still have the same two events, so actually the numerator wouldn't change at all. Because remember we said, it doesn't matter if I write O and LM or LM and O, that's the same thing. The only difference would be, now I'd be dividing by, and I've got so many arrows going here. Now, since the older than 55 is over here, that's what I'm conditioning on, it would change my denominator. Yep. Any other questions on that one? Okay, so the next one asks us about independence, okay? So the very definition of independence, right, if we want to look at the kind of general form, and then we'll work through our example, is that if the conditional probability of an event, so this is the conditional probability of A, if that's the same thing as the unconditional probability of A, then what we're saying is it doesn't matter that we knew B, it didn't change the underlying probability. So these events are independent, right? It doesn't matter if I know B or not, the probability of A hasn't changed. Now I can't get this directly from the table, right? But what I can do is calculate that just like we did in the previous problem, right? As an intersection divided by whatever I'm conditioning on. Now, if this is the definition of independence, so if this holds, we say they're independent. Right? Now notice, the conditional probability, I have to be comparing it to the unconditional probability. I have to be comparing the same event. So if I look here and I say, okay, is supporting legalization of marijuana and being older than 55, are they independent events? So I'm thinking about O and LM here. If I go through these and just think about which of these answers make sense, it doesn't, let's ignore the even yes, are they independent, or no, they're not independent first. Here, I'm comparing the conditional probability of O to the unconditional probability of O. But here I'm comparing the conditional probability of LM to the unconditional probability of O. Well, that doesn't tell me anything, right? I need to be comparing the same event here. So B doesn't make any sense. Conditional probability of O, unconditional probability of LM. Not comparing the same event. That doesn't make any sense. Same thing here, not comparing the same event. I could actually rule all three of these out just by remembering this general kind of definition of independence, and I don't even have to check to see if they're independent. Okay? Now, if I did want to check to see if they're independent, what I'm thinking about there now is, so let's say, you know, instead I had this same answer, but yes, because they were equal, right? So there's two viable answers. Here there's not, but what if there was? So I'd be checking to see if this holds, right? Well, the probability that someone is older than 55 and wants marijuana legalized, well, actually we just found that, right? Or sorry, not the and, the conditional probability, which was the intersection divided by what we conditioned on. We actually already found this, right? So it's the same thing, right? We've got the conditional probability. We go ahead, plug in the intersection divided by what we conditioned on, and we got that 0.212. What's the probability someone's older than 55? Go up here, 0.25. Are those two things the same value? No. So we say these are not independent. Or here, right? No, they're not independent, right? No, they're not independent. Okay. So that's why A is kind of the correct answer there. Now, if we had done this work and found that they in fact were the same value, then the correct answer would have been, right? Yes, they are independent because that conditional probability was the same as the unconditional. Now, that wasn't the case here, but I'm just saying if it was, that would be a possible answer. I know I jumped to the previous problem there to kind of answer one. Was there any questions on that? Does that make sense what we did there? Okay. Let's go. Let's do this one. This is pretty easy. If we have time at the end here, I might revisit this to kind of mention something. So remind me of that if we have a minute or two left, and I'm trying to wrap things up. Are these two events, so wanting marijuana legalized and being under 55, which would be O complement, right? Not being, you know, being younger than 55 or under the age, are they mutually exclusive events? Okay. So the only time we have mutually, so this was the definition of independence. The only time events are mutually exclusive is when they can't happen at the same time, right? So we said if they can't happen at the same time, that would mean that the intersection of those two would have to be 0, right? Two things can't happen at the same time. Well, what's the probability they happen at the same time? Well, they can't, so the probability is 0, right? So for us, that's O complement and wanting marijuana legalized, right? So being younger than 55 and wanting marijuana legalized, they're mutually exclusive if that intersection of the two is equal to 0. Well, I can answer this one pretty quick. If I go back up to this contingency table, are any of these events mutually exclusive? All the intersections were non-zero values, so no, none of them can be mutually exclusive. The only way I would have mutually exclusive events here is if I saw a 0 in that contingency table. So no, they're not mutually exclusive, and it's because the intersection, so no, they're not, because we didn't see any 0, so now we know we're between C and D, but it's because the intersection was not equal to 0, right? The union could be, it doesn't matter what the union is. The union has no bearing on whether or not they're mutually exclusive. So right away, if we're looking at this, the unions here don't make any, we could have ruled out B and C right away as well. And then once we go to the table and see there's no 0s, well, now we know that they're not mutually exclusive. We could have ruled A out right, from there. The only thing we're left with is D, right? That no, they're not mutually exclusive because the intersection of those two things is not 0. Does that make sense why I was kind of ruling these other ones out, right? We don't care about the union of any events here for mutual exclusivity. And then up here, well, we didn't see any 0s in that table, so there are no intersections that are equal to 0. Right? We didn't see any. Right? So right away we could rule everything out, kind of knowing the answer is D. But that came from kind of knowing this general definition of being mutually exclusive. Questions on that? Okay with that? Okay. Let me double check the chat. I didn't see anything pop up. So we're going to come back to this. When I record on Wednesday, I'll record working through 10 through 13. That'll be part of that recording. So if you want to watch that Wednesday or Thursday, whenever you want to watch that, you know, that'll be out there after Wednesday. Okay. We're going to skip down a little bit and talk about something that's kind of closer to what we've been working through lately. We look at this schedule. This is the number of weeks someone is sick in February, right? So I was either, you know, if I think about February, I can break it up into 4 weeks, right? It's 28 days long, so I've got 4 weeks. Was I sick in the first week? Was I sick in the second week, third, right? So the number of weeks I could have been sick during, well, 0. I could have been sick in 1 of those weeks, 2 of those weeks, 3 of those weeks, or all 4, right? Hopefully not the latter. But if I want an expected number of weeks or the mean number of sick weeks in February, how could I find that, right? Well, I don't want to simply use a mean, the general mean equation, which is add up these numbers and divide by the number of numbers I have. If I do that, I'm ignoring the fact that it's much more likely I'm not sick in any week than it is to be sick in all weeks, right? So I've got these different probabilities associated with seeing these different numbers of outcomes. And that they're discrete, right? I have to be sick in 0, 1, 2, 3, or 4 weeks. So what I'm really looking at here, if I go to my formula sheet, minimize this for a second. Scroll down here. Here I have grouped the 2 equations that you would kind of need to use for a mean or a discrete random variable. So first is the mean, and then I have the equation of the variance. So we're looking for the mean or the expected value. So what it tells us to do is go through every single outcome, multiply that outcome by the value, multiply the value of that outcome by the probability we see that outcome occur, and then add them all up. Okay. So I go back to my example, right? I've got the mean of this discrete random variable. I pull up in the answer key, my bad. So what we're going to do is go through every outcome and multiply it by the probability that we see that outcome occur. So the very first one that we could see occur is that someone is sick for 0 weeks times the probability they get sick 0 of the 4 weeks was 0.45. Add to that the second outcome, which was being sick for 1 of those weeks, times the probability we're sick for 1 of those weeks. Plus the next outcome of 2 weeks times the probability we see 2 weeks, plus the next outcome of 3 times the probability we see someone sick for 3 weeks, and then the last outcome of 4, multiply the probability we see someone sick for all 4 weeks. Okay. Now, typically, when we're using these weights, we would then divide by the sum of our weights. But right, if we looked at that formula sheet, and move this thing out of the way a little bit. My weights are probabilities. So if I add up the probability of every possible outcome, some of those weights or those probabilities should add up to 1. All right, so we essentially can ignore that. That's why there isn't a denominator here. Why complicate it? All right. So we can go ahead, add these up, and I think we get 1.05. Okay. But if we think about these possible answers, right, I probably could have ruled 2 of them out pretty safely, right? So if I look at D here, why could I maybe rule out that the mean was 2? If the mean was 2, what should be true about the values below that mean of 2 and the kind of values above that mean of 2? Yeah, they should be about equally as likely, right? It could be that, you know, they don't have to be the exact same probabilities, but they have to be close to each other, right? Well, if we look here, 0 and 1 are way more likely than seeing 3 and 4. So automatically we know we're not going to be smack dab in the middle of these values, right? We're going to be like a little bit closer to 0, right? It's going to be dragged down. Now, how much? That's hard to say, you know, without having like a really gifted mind being able to visualize these probabilities. But two we can kind of rule out because the values below that are much more likely than the values above it. Now, 0.2 is probably safe to rule out. Why? I mean, it's so close to 0 that it would have to be that the outcome of 0 would be much more likely than probably 0.4. If we had, probably of 0.8 or 0.9, that would pull that mean really, really close to 0, and then we might see a mean of 0.2. But right, given that we have the probability of seeing 1 and 2, like these are not, very, very close to 0, it's very unlikely that the mean is going to be 0.2 or that low. So if I'm throwing darts at this one, I'm probably going to throw a dart at B or C, right? I'm going to try to hit B or C. One of those is more, a likely answer. Sure enough, if we actually compute it, right, it is 1.05. But I'm just trying to talk through the principles for helping us at least, if we got stuck on this one, I don't know what equation to use. If I just think about what I'm doing, I'm calculating the middle point of these outcomes, but I know that some of them are going to influence that middle point more than others, right? And just thinking through those principles, we could have ruled this down to probably, guessing between 2 instead of 4 options. So I know students don't like multiple choice sometimes, and they think it's, I don't know, hurts their grade more. I've tried writing questions with several more short answer or several more multiple choice, and I get about the same average either way. Sometimes, though, with these multiple choice problems, it helps. It helps improve grades if you aren't really sure where to begin, but you have or what formulas to use, but you have a really good understanding of the principles, right? Now, in a short answer, it doesn't matter how good your understanding of your principles are. If you don't know what function or equation you use, you're not going to get any points there, right? So I think kind of thinking through what answers you can rule out is a really good way to kind of work through some of these multiple choice questions. Okay. Any questions on that one before we keep moving? I don't think there's anything in the chat. All right, so this one's are a little bit unique, and if you're looking at other problems in the practice exam, you might see this as well. So anytime I write a problem where it's kind of related to the previous problem, well, I don't want to have cascading errors, right? If I asked you here to find me the standard deviation or the variance for this number of sick weeks, well, if you got the mean wrong, you're sure as hell going to get the variance wrong, right? You need the mean to calculate the variance. So if you get 14 wrong, there's no way you can get 15 right unless you guess, right? So I don't want that to be the case. So what I do is I give everybody kind of the same starting point. Assume that the average or the mean number of sick weeks you found was 2, right? So we're all starting out with a mean of 2. That's not the correct mean, but I'm giving you this assumed value to use, okay? So we have this mean of 2, right? And we want to calculate the standard deviation, right? Which is just a scaled version of the variance, which tells us something about how much do these outcomes vary from this middle point, right? Well, if I look at these possible answers, which ones can I rule out right away? Yeah, negative, right? We know variances and standard deviations have to be positive, right? Because it doesn't matter if we're varying from that mean above it or varying below it, that still counts as variation, right? There's no negative values there. So if we go to our formula sheet, how can we actually compute this? We can rule out one of the answers, but we still got 3 we got to choose between. Well, here's my discrete random variable equations. Here's the variance, right? Now, I don't have the standard deviation here, but once I find the variance, what's the only other step I need to use to find the standard deviation? Not square it, right? If I'm going from the variance to the standard deviation, I'm going to take the square root, yep. So I always kind of did this last class as well. So, right, we always have to calculate the variance first, and then to get the standard deviation, what we're going to do, that's just sigma, so we would have to take the square root of our variance. So we're going to first find our variance. We're going to go through every outcome, subtract that mean of 2 that we were given, square that deviation, and then multiply by the probability we saw that outcome for x. So if we go back here, what does that look like for us? All right. So how do I calculate this variance? I'm going to take that first outcome of 0, subtract that mean I was given of 2, right? We were assumed that mean was 2. Square that deviation, and then multiply it by the probability I see 0 occur, which was 0.45. Then add to that the next outcome of 1, subtract that mean of 2, square it, multiply that by the probability we see 1 occur, which was 0.25. won't talk through the rest of these, otherwise I'll probably take a little bit more time than I want. But we just go through every possible outcome, subtract that mean, square the value, and then multiply it by the probability that we saw that value occur. So I'm just going to get this all written out for us. So if you're following along, you kind of have the complete thing. Right? Now, you could put this all into your calculator at one time. Another way to do this, and obviously you're not going to have the ability to insert a column next to it on the exam, but what you could do is on a sheet of paper in front of you, write your own column where you have the different numbers of weeks, and you say, okay, for the first one, it's going to be 0 minus 2, so that's 2, squared is 4, times 0.45, so I get what, 0.9, is that, no, 85? 1.85? Yeah, okay. No, it should be 0.85, right? Am I thinking about this right? No, it is 1.85. 0.45 times 4. There we go, 1.8, my bad. I see what you're saying. Okay. Next one, 1 minus 2. Negative 1 squared is 1 times 0.25. 0.25, right? And I could go through and do this for every outcome and then add them all up, right? So that's a way to kind of prevent from making maybe parentheses errors in your calculator or something like that. Okay. Any questions on that one? So if we get this all into our calculator correctly, we should get 2.35. So we circle A and we're done, right? What did I just calculate? Calculated the variance. What did the problem want? Standard deviation. So the only other thing I have to do here is take the square root. That would give me my standard deviation. That's the 1.53-ish, okay, for rounding the second decimal. So this is an example where I might give you an assumed value and then you use that, okay, so that you don't have kind of cascading errors here. Okay. Any questions on that one? Okay. All right, so one more problem in this kind of batch. So let's say I wanted to know what's the probability that you're sick for less than 2 weeks in February. Okay. So i.e., what's the probability that X is less than 2? So how am I going to find that? Right? Well, we did a lot of this with binomial and Poisson. It didn't really work through as many with, I don't even know if I completely worked through one with these discrete random variables, but binomial and Poisson variables are discrete random variables, are just very unique types, right? So if I want the probability that X is less than 2, and I think about this as event A, well, I can never see, these are mutually exclusive events. I can't see somebody be sick for 0 weeks and sick for 3 of the weeks, right? So this is, so when I think about the probability that X is less than 2, what I'm going to do is think about all the possible outcomes that meet this criteria, and add the probability up of each one of those outcomes. So what's the very first outcome or number of sick weeks that would meet the criteria of being less than 2? Well, 0 is one of them. What was the very first outcome that would meet this criteria? Yeah, X is equal to 1, right? Yes, it doesn't. When I say first, I'm thinking about the next lowest. But yeah, right? We've only got 2 outcomes that meet this criteria because I don't have a less than sign here, right? It has to be less than 2. Well, it's discrete. So the very first value that's less than 2 is actually 1, right? And now it's really easy. Unlike our binomial and Poisson, we don't have to use a probability mass function. I just use this table, right? Here is my probability mass function. So the probability X is equal to 0 is 0.45. Probability that it's equal to 1 is 0.25, right? And so I get what, 0.7 here? We're done, right? Easy as that. Now, this is where we have to be careful, like, of the equalities. So if I had instead, what's the probability X is less than or equal to 2? Well, now the first outcome that really meets this criteria would be X can now be 2. So then I have to add in the additional 0.15, right? And I get 0.85. So we got to be careful with that equality there. Okay. What if I instead wanted the probability that X was greater than or equal to 3? What outcomes fit this criteria? X could be, yep. So X could be 3 or X could be 4, right? So we'll add those probabilities together. Once again, just a matter of going and grabbing those from the table. 0.1 is 0.05. Get that 0.5. Okay. Any questions on that one? Shouldn't be too. That one shouldn't be too bad. As long as we be careful about the equalities, that one should be relatively easy. I say relative. So the next batch of questions we have, and we went a little bit quicker, but I do want to return to that one. So I'll start with this binomial. I'll kind of show you a couple things to kind of think about. And then I might return to that one about independence to show you an additional check that could be used like on a short answer that wasn't, the one that we worked through. So let's say I've got approximately 64% of people in the US have a visual impairment, right? So they need, I don't know, glasses or surgery or something. Suppose we select 15 people at random, right? What's the expected number of people who have a visual impairment? Yeah, so why did you know right away? I mean, I don't know, maybe you did the math in your head of the formula, but actually there's a way where even looking at these, first of all, which of these can I rule out right away? I mean, very quickly. What would the percent have to be for it to be 15 out of 15 people? 100%, right? That doesn't make any sense, right? So really this is one of those intuitive ones where we said, well, if I had 100 people, how many people would need, or have a visual impairment? 64. What'd you do in your head there? You actually were, technically using this equation, which was taking the number of trials n times the probability of success in any one trial p. So here, this batch of equations is our binomial distribution equations. Here's our probability mass function. Here's our mean. Here's our variance. Here's our standard deviation. So to get the mean, it's simply n times p. So here for us, that was what? N was 15. Probability of success is 0.64. If I multiply this, it was 9.6. Right? So I could have also asked you what's the mean and what's the variance. There is just a matter of here. We've got our binomial distribution equations. I just plug in my n and p into this equation to get my variance. Okay? Didn't ask you that in this problem, but it could ask you that on a problem like this. Now, another thing to just kind of point out so we start to think about some of these principles. Even if I couldn't do this math in my head, why do you know it's not B and C? Here's a trick to kind of put a bounds on it, right? So 64% is more than half of the people, right? So let's use the 100 people example because it's easier. If I have 100 people, I know that 50% of 100 is 50 people. I have that 64% of people will have a visual impairment, so I know that it's going to be greater than 50, right? Same thing here. If I have 15 people, I know that more than half of them have a visual impairment. What would half of 15 be? 7.5. So I know that more than 7.5 people are expected to have a visual impairment. Only one of these values is greater than 7.5. Right? So even if I don't know, if I didn't have a calculator and I want to do this, couldn't do this in my head, 0.64 times 15, just looking at these options, I know that it has to be A. Well, I mean, I guess D is greater than 7.5, but it's also less than 100, right? We could put upper and lower bounds on where this probability has to be, or where this expected number of people has to be. I mean, this one, we'll talk through, and then I'll kind of return. This one shouldn't be too bad. If I have the same setup, but I want to know what's the probability 10 of the 15 have a visual impairment. I go to my formula sheet. If I want the probability of any one number of successes, the probability X is equal to, I think it was, what did I say now, 10 there. I have to use this equation, right? My number of trials was the 15 people, so that was N. Probability of success was 0.64. And now my X, the number of, the probability I'm trying to, or the number I'm trying to find the probability of is 10, right? So it's a matter of plugging those values in and being able to work this out in our calculator. So this is where we said it's important to know where your factorial button is, right? Or if we write this out, being able to see like what could cancel here, okay? But really this is practice at, I can write this out for you, but I mean, really once we have NX and P, it's a matter of you being comfortable entering that formula into your calculator and being able to get the correct answer. Okay. If we look here, though, I mean, which of these, I mean, if I think about the answer of D here, right? So on average, we said 9.6 people have a visual impairment out of 15. So 9 and 10 are going to be pretty likely outcomes, right? Let's just assume for a second they're the only two outcomes we could see. We know it's not true. We could actually see anything from 0 to 15. But even if they were the only two outcomes, and let's say they're approximately equally as likely. So if they're the only two outcomes and they're about equally as likely because they're both kind of on either side of the mean there, what would the probability of each one be? About 50%, right? 0.5. So if I'm thinking about the probability of 10, even if that was a scenario, I eliminated a ton of the other outcomes and I only had two that were, you know, both equally as likely, D doesn't make any sense. For the probability to be as high as 0.9, right, that would mean that that's really the only outcome that we're typically seeing. Well, we know here that 9.6 is the average outcome we see, or that's our mean. So on most cases, we're going to see either 9 or we'll see 10. They'd probably be equally as likely. So if we're going to be equally as likely, you can't have a probability as high as 0.9. You know, anytime we find these probabilities for a binomial, you can almost cap it at 0.5. Like it's unlikely that something is ever going to have a probability of occurring of 0.5 or higher, right? Now, you know, how much lower can you go? I don't know if B or C. I don't know which one makes any more sense there. It's you know, now we can't really say anything about that. But anything over 0.5 doesn't really make a whole lot of sense in the context of this example. And I also, in explaining that, eliminated all the other outcomes that we will see, which are 0 through 8 and then 11 through 15, right? So we know the probability can't be too high here because we have so many outcomes that we could see, you know, and 9 is going to be just about as equally as likely as 10, and really 11 and 7 aren't that far away from the mean. They won't be that unlikely. So for us to get a probability of any one outcome of being as high as almost 0.7 or 0.9 doesn't really make a whole lot of sense for what we're doing in this example. If I'm just taking a shot in the dark here, just off the principles, and maybe I can't put that formula into my calculator, I'm going to guess B or C here. And I don't, in fact, if we work it out, wouldn't be something if I explained all this and then it ends up being 0.9. No. But no, these principles we can see, yeah, so it ends up being 0.2. Right? There's no way we could see it be as high as kind of that 0.7 or 0.9. This doesn't make sense for what we're doing with a binomial with this probability. Now, if I instead said like, well, let's assume that the probability someone has a visual impairment is 0.0001. Well, yeah, then maybe the probability we see 0 is that high, but for the sake of the numbers we have here, it doesn't make a lot of sense. So the one thing, if we had a couple minutes, I did want to go back and make sure I mention. So we have this idea of independence that we talked about earlier, right, for 8. And we were checking the actual definition. But something on your formula sheet I wanted to point out, which was we have these special conditions. So this was a condition that held for mutually exclusive events. Why? Because typically when we find the union, we add up the probability of two events and subtract what we double counted or the overlap or the intersection. Well, if they're mutually exclusive, there is no intersection, and so this equation actually holds. The other special condition we have is if they're independent events, we know this equation will hold as well. And that was something we could check very easy using the contingency tables because I can find the intersection of two events from one of those top 4 left cells, and I can find the probability of each event by just going over the total, right? So I can check to see if they're independent or not, right, using this special condition as well. If this holds and these two things are equal, they're independent. If it doesn't hold and they're not equal, we would say they're not independent. Right? Now, it didn't help us a lot in identifying what the actual definition of independence is. That special condition is just kind of a byproduct of if two things are independent, this other condition also ends up holding as well. Okay? So just kind of pointing out more things on that formula sheet for you, so we can kind of hopefully get everything filled in there. Okay. All right. Any questions on anything? Excuse me before I let you get out of here today. So like I said, I won't be at 1 o'clock here filming. I'll be here at noon. If you want to show up, you can. If you don't, there's absolutely no pressure. There'll be like no online quizzes this week. We're just doing review. You can watch that video once it's posted on Thursday or Friday or later in the day, Wednesday, whenever you want. You don't have to do anything Wednesday. You can take the whole day off. Okay? Yeah, so we don't have class technically. I'm just going to be in here filming. If you want to show up, you can. If you don't, yeah, yep. All right, so I will see all of you again, hopefully on Friday for review, or if you want to stop by on Wednesday or sign on to the Zoom meeting, you can do that as well. Okay?
Can you help me